Here we go. Classified information. Our essential question is, how can elements be classified and how can compounds be classified? So your first question on page 12 wants you to identify, and as you read, it wants you to underline ways in which elements are organized in the periodic table. I will be getting you a periodic table that will stay in your binder. So you will have that as part of your notebook. And so if you've ever looked at the periodic table, it has changed since when I was in high school. With the advent of better technology and scientific tools, we've been able to make and discover other elements. And so I will try to make sure that I get a link to the interactive periodic table for you, in which you can, I don't think it's linked here. Nope. And so this is a picture interactive periodic table because we don't usually think of the elements themselves. We think about how we use them or take advantage of them. And so we will be learning in our next lesson about the periodic table, why it's arranged the way it is, and what the position of each element means. So if I close my eyes and touched a place on the periodic table, you could describe to me what that element's characteristics were just based on where I landed in the periodic table without it being labeled. So the rows have meaning, the columns have meaning, and we will learn about that when we talk about the periodic table. I kind of like Einsteinian. This one's named after Madame Curie. And so you should have picked up the handout today, hopefully. If not, it's either in the front table or in the back in the extra copies. And you are going to go through and you're going to label the metals, the nonmetals, and the metalloids. You will have to know more specific things about the periodic table, but this is a good start to start planning into your brain where these three different types of elements are. So then we're going to talk about how compounds can be classified. I guess we should go back here. So these are arranged mostly by the number of protons they have and how they interact. And so hydrogen has one proton, and you can see it up in the top left, and all the way down at the bottom, you can see that the atomic number is greater, more than 100. And so it starts with one proton and goes all the way down. Where they are in the columns determines how they react with other substances. Over on the right, you can see the noble gases. So they tend to not react at all with other elements because they have a stable outer shell. If you remember from the gizmo building an atom or an element, those valence electrons, once there's 8, at least in the first couple of shells, it's stable. And we'll be talking about that more when we get into bonding. But each row and column means something. So then we're going to switch and talk about how compounds can be classified. Remember, a compound is when elements combine together. And so in life science, in biology and in life, we classify compounds usually as being organic versus inorganic. If you go to the grocery store, you can see that some fruits and vegetables will be labeled organic. That isn't this meaning. This isn't what they're talking about. In the grocery store, they're meaning that those fruits and vegetables are grown without any pesticides or herbicides or added fertilizers and stuff like that. That's not what this word means here. Organic means has the element carbon. So in science, when you're talking about something being organic, it has carbon. We are a life-based form based on the element carbon versus inorganic. N means without or take out or not. And so inorganic does not have the element carbon. So this question wants you to read and look how compounds can be classified. And you have some fill in the blanks, as you can see with the green arrows here. So we're getting ready to talk about pH and their role in the body. So here we go with pH. pH is actually the measure of the log of how many hydrogen ions are in something, usually a solution. We're not going to get that crazy. So as you move to the left of the pH scale, you get more H pluses. If you move to the right, you get more OH negatives, which are the hydroxide ion. We'll be talking about ions later. An ion, ION, is simply a charged particle. When an atom gives up an electron, it becomes positive because it gives away some of that negativeness. When an atom gains an electron or electrons, it becomes more negative. And so if we were to mix the H plus ions on the left with the OH ions on the right, we get into the middle of the scale, which is water, which means that there's an equal number of H pluses as there are OH negatives. As you go to the left, things become more acidic. So something with a pH of 2 is more acidic than something with a pH of 6. So 2 would have more hydrogen ions than the pH of 6. The pH of 6 would have more hydroxide ions than the pH of 2. Same thing is true for the other side of the pH scale. As you go farther to the right, you get a stronger base. So something with a pH of 8 is a weaker base, and something with a pH of 13 would be a strong base. Both things, acid or base, are caustic, which means they could cause problems. If you have a strong base hit your skin, it's going to burn the same way that an acid hits your skin, it's going to burn. So we have to be careful when we're handling chemicals and keep a note of pH. Your blood has about the pH around 7. The stomach acid in your stomach, hydrochloric, and other gastric juices have a pH about 1 to 2. Windex is a classic base, and it's usually around an 8. Where would you put Coke, the drink Coke, Coca-Cola? Would it be neutral? Would it be a base? Would it be an acid? It's actually acidic. So the next way we can classify compounds is what they do in the body. So we have 4 main groups. We have nucleic acids, which are, all of these are organic, by the way, meaning that they have carbon. We have nucleic acids, carbohydrates, lipids, and proteins. Nucleic acids carry our genetic information like DNA and RNA. Carbohydrates are used to be broken down to make ATP, which is the energy molecule of our body. Examples of carbohydrates would be glucose, fructose, sucrose. Polysaccharides would be starch. Lipids store energy, so they're really just long chains of glucose tied to a cholesterol molecule or a glycerol. And they're made up of fatty acids and the glycerol molecule. They insulate the body, they store energy. Then we go to proteins. Proteins help with movement, structure. They function in other ways besides that in the body, like hormones. And so proteins are made of amino acids. Those are its monomer. Nucleic acids are made of sugars, phosphates, and bases. And carbohydrates are made of carbon, usually monosaccharides. The classic example of monosaccharide is glucose. And that's it for that.